So what is the first most important thing when we're talking about an experiment? Random. We need random assignment. Have to have random assignment. Random assignment into how many groups? In this case, they split them into 2 groups. Does it always have to be 2? No, you can have more than one experimental case. You have to have a control. You have to have at least one experimental group, but you can have more than one. So they get split into 2 groups. One of their groups got 34 people, the other one got 16. Why didn't they decide to split them up evenly? I don't know, but they didn't. As long as you use random assignment, it's okay. What condition did they give group 1? The yawn seed. What about group 2? No yawn. So which one is our control group? Group 2. Group 2 is our control. Oh, sorry. Let me fix that. There we go. What did they do after they had conducted their experiment with the yawn seed and the no yawn seed? They compared the proportions. What proportion of the yawn seed group yawned? This is contained in that table down below. What proportion of the yawn seed group yawned?
34.
34 out of 34 yawned?
Oh, no, 10, sorry.
10 out of 34 yawned. And the no yawn seed group, how many of those people ended up yawning anyway?
4.
Out of?
16.
4 out of 16, yes. So 4 out of 16, I know that that is 25% or 0.25. What is 10 out of 34? Let's take it out to 2 decimal places here. What is 10 out of 34? .29. All right, so that gets us right here. The true proportion, or we're going to call P1 the true proportion of yes yawn seed people who yawn. P1 hat then would be from our group 1. Is P1 hat the same as P1? No. P1 is the true proportion of people who yawn with a yawn seed, whatever that happens to be. In our experiment, what we observed was 10 out of 34 did it. P2 is the true proportion of people that yawn if they don't get a yawn seed. What was the observed proportion for P2? 0.25, yes. What's the difference in those 2 proportions? 0.04. Does that seem like a very big difference between the group? Do you guys remember from the video on Friday what the Mythbusters guys said when they compared those proportions?
It does. Like he said, the yawn seed does.
Yeah, they said like the yawn seed will, like there's a cause and effect here. If you're in a room and somebody yawns, you're more likely to yawn. Does the data provide some evidence that yawning is contagious? Yeah. Why?
Both of them are over 5%.
True. But what evidence do we have that yawning is contagious? There is some here. The proportions. So what evidence do you have when you look at the proportions? Yeah. 29% chance if you're in the yawn seed group, only a 25% chance if you're in the no yawn seed group. People given the yawn seed yawned more often than those who were not given the yawn seed. 29 is greater than 25, or 0.29 is greater than 0.25. So Adam and Jamie used that data to conclude that yawning was contagious. I agree that we have some evidence. Do you guys find it convincing or compelling? What's the difference between those two proportions again? 0.04. That's not a very big difference in proportions, right? What else could possibly account for this difference that we're seeing? It's possible that yawning is contagious. What's the other possibility with a difference that small?
Some people were more tired.
Some people were more tired. Maybe the people that got put in the yawn seed group were just more tired. And it's not actually, like maybe the random assignment is accounting for this difference and not the yawn seed. A difference of 0.04 doesn't seem like a big enough difference. It could have happened purely by chance from the random assignment. So we're going to do an activity to determine whether or not this difference, this 0.04 that they saw, is that statistically significant or not? So we are going to recreate their experiment using a different random assignment. How many people total in this experiment ended up yawning? 14 out of 50 people total. So 14 people yawned, and that means how many people didn't end up yawning at all? 36 people didn't yawn at all. So I'm going to need you guys to get into partner groups. I'm going to pass out little cards that have 14 people that are making a yawning face and 36 people that are not yawning. We're going to mix these up, and you're going to randomly assign them to two groups. One of them will have 34 in the group. The other one will have 16. I want you to do this upside down and then flip them over and look at what your proportion is. Before we do that, though, I want to write down our null hypothesis. The null hypothesis is not what Adam and Jamie saw in their experiment. The null hypothesis, we're going to assume that this just happened by chance. If this just happened by chance, you're yawning already. I'm like yawning, talking about yawning. If this just happened by chance, what would be the difference in proportions between these two groups? 0. So our null hypothesis is that when I subtract these two proportions, it's going to come out to be 0. Null hypothesis, yawning is not contagious. All right, so I need you guys to get into groups of 2. And you're going to repeat this experiment 3 times. So this is just on these little cards. It's going to be hard to like shuffle them like you would a deck of cards, but you can lay them upside down and mix them around. And then you are going to randomly assign them into 2 groups. One group gets 34, the other group gets 16. You are going to record the proportion of people who yawned in each group. And you're going to do this 3 times. So your P hat 1, this is going to be your 34 card group. P hat 2, that's going to be your 16 card group. You're going to write down those 2 proportions, and then you're going to do the difference between those, P1 minus P2. All right. You're going to repeat this 3 times, and then we're going to put the difference in proportions on a dot plot. Got it? All right. Once you have your groups, please come up and grab a set of 50 cards. There you are. Go. Carolyn, you want to come up and work with Tucker? And so yeah, spread them out, mix them up. Assign 34 to one group, that'll be your P hat 1. Assign the remaining 16 to the P hat 2 group. P2 is your 16 group. P1 is your 34 person group. You're going to write down your proportion in group 1. You're going to write down your proportion in group 2. You're going to subtract those proportions, so turn them into decimals. And then you'll do the experiment again. You gotta do it 3 times total. 3 times total. Whenever it is that you guys get to the end of your 3rd trial, your 3rd simulation, then you'll come up here and you'll put 3 dots up on the screen that represents the 3 differences in proportions. Yeah, it doesn't matter, but yeah, one of you will come up and put the 3 dots up there. So one for each of the differences. Two groups down. Awesome. Thank you, Lola. All right, if your group is already done putting your dots up, go ahead and start copying this down into your notes. I think we're just waiting on 3 more dots. That's good. All right, I think we have all of them up there. Let me count. We should have 27 because we had 9 groups and everybody did 3 trials. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Perfect. We got 27 dots up here. In what percent of our trials did the difference in proportion exceed or equal 4%, what the Mythbusters experiment got? So where is 4% up here? Just to the right of 0. So it's that second little mark there. So right here, because this was the Mythbusters result. Let me write that up a little higher. So like I said, we had 27 dots up here because we had 9 groups. So out of 27, how many of them had the Mythbusters result or larger?
15.
I think I got 14. 1, 2, oops, quiet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I got 14. Okay. So 14 out of 27. What is that as a decimal? 0.52. This is our p-value. I want to interpret that p-value. What is that telling me? What assumption did we make at the beginning? Yes. So assuming HO is true, yawning is not contagious. So we always start like that when we're talking about a p-value. First, we say what we assumed. Assuming the null is true, tell me what that is. Then what? Yes, there is a 0.52 probability, or 52%. Of getting what? 0.04 or higher. So here we want to say what we've done of getting a P1 hat minus P2 hat of 0.04, not 0.0, yeah, 0.04, sorry, I was getting my decimal in the wrong spot, of 0.04 or greater. By what? Just by chance. So that's my interpretation of the p-value. What conclusion can we reach from that? Would we reject or fail to reject the null? Fail to reject. Why fail to reject? P-value is too high. Because when the... There we go. P-value is not low in this case. Because 0.52 is quite a bit greater than 0.05, we fail to reject the null hypothesis. So does that mean we do or do not have convincing evidence for the alternative? We do not. If we fail to reject the null, then we're going to stay with that. And that means I don't have enough convincing evidence to reject it and go with the alternative. So if we fail to reject the null hypothesis, we do not have convincing evidence of what the alternative was. So I'd say, and we do not have convincing evidence that yawning is contagious. This is where we stick our context back in. We're going to state right there what the alternative was. The alternative was that yawning was contagious, because our null was that it was not. We do not have convincing evidence, because when it was just left up to chance, we saw the difference in proportions that they got more than half the time. So we busted the Mythbusters, because they said it was contagious. All right, let's get our big ideas, and we're going to do the check your understanding. All right, so our hypotheses. The null is always going to be that there's no difference in these two proportions. Null is that these two are actually equal. Whenever we're looking at a difference, that's our null. The alternative can be one of these three things. We can think that P1 minus P2 is less than 0, so we think the proportion 2 is the bigger one. We can think P1 minus P2 is greater than 0, so proportion 1 is bigger. Or we could just think that they're not equal. I don't know whether it's bigger or smaller, I just think they're not equal. You have to define P1 minus P2 with direction. So you would have to tell me, like, P1 minus P2. And then you think it's greater, or sorry, less than, greater, or not equal. We have our three conditions that we have to check. We either need random samples so that we can generalize to our population, or we have to have random assignment if we're trying to show cause. 10% condition, we only have to check this when we are sampling without replacement. So if we're looking at random samples, we have to check the 10% condition. If we're looking at an experiment with random assignment, we do not have to check the 10% condition. And for our large counts, we have to use what's called P combined. To find P combined, we take our observations from population 1 and population 2 over the total in group 1 and group 2. So we're going to find a P hat combined there, and that's what we use for our large counts here. In the check your understanding section, I just want you to do the first 2 steps of our 4 steps. So the state and the plan. We will go over the check your understanding in about 5 minutes. What is the parameter here? What are we trying to find? Yes, and the way we would define that is P1 minus P2. So we're going to name it P1 minus P2, and that is the true proportion in difference of people who would yawn. And then you have to give me the direction that you're doing. So yawn seed minus no yawn seed. Tell me what P1 and P2 are that you're subtracting. What was the null, or what is the null hypothesis here? Yes, p hat 1 minus p hat 2 equals 0. Yawning is not contagious. What would our alternative hypothesis be? Is it greater than 0, less than 0, or just not equal to 0? Based on what Adam and Jamie observed, greater than. They thought that yawning was contagious based on their results. So proportion 1 minus proportion 2 should be greater than 0. Yawn seed should be bigger than no yawn seed. What was their statistic? Yes, 0.04. What significance level did we use? 0.05. So alpha is 0.05. Our alpha level is always our significance level. All right. So far, so good on this part? Keep that up there for you guys. What would the name of the procedure be that we used? 2 sample. Z-test. Not for P.
Oh, P hat minus.
For P1 minus P2. No P hats when we're talking about our test, because we're trying to find the true difference in proportion. So this is a 2 sample Z-test for P1 minus P2. Conditions. Talk to me about randomness. How did they satisfy the random condition? Yes. Oh. They used random assignment. This is so we can show causation. Second condition we need to check is what one? 10%. Did we have random samples? No. So we don't have to check this condition. No sampling. When we pick random samples is when we have to check our random or our 10%. And only when we sample without replacement do we have to check this. When we're doing an experiment with random assignment, we don't have to check our 10% condition. And third, what do we have to check? Law of large counts. What is our P combined? X1 plus X2, so that would be 14 out of 50, yes. So 34, 14 out of 50 is 0.28. That gives me 9.5, that's not bigger than 10. When I do N1 times 1 minus P hat combined, that works, but it failed the first one. Same thing in population 2. 16 times 0.28, I'm going to get 4.5. Fails my large counts condition. Why does that matter? It's not approximately normal, so I can't use a normal curve to approximate this. That's why we did a simulation here. Tomorrow, you guys are going to want to do one of these start to finish with a partner or a small group. I can go right back to that in just a moment. There we go. Have a fantastic rest of your day, guys. Oh, thank you so much. Thank you.